Okay. Can you guys hear me?
Yeah.
Yeah, we can hear
Yes. Okay, great. All right. So this is the second half for today, right? Of our session. This will be a second video that I will post on YouTube. Okay. Let's see. Let's go back to sharing documents. Okay, so this is where I was. All right, so can you guys see the website?
Yeah, we can.
Yep.
Yeah. Yep.
All right, yeah. So this is where I left off, correct? So here, as I said, this is a place where I like, it's a good place to put things. So you can always check Brightspace or check here for the calendar organization. I will post links to relevant things. Like I notice here, I haven't put the link to Anaconda yet. I will do that. I think I put this on Brightspace, but I just haven't added it here. So anyway, so like today we have two videos. So one video will be here. The other video will be here for August 26th and so on. So you might imagine how that is. I will also post relevant links to code or things like that. Okay. So we have class basically these 2 weeks, and then September 7th, as you can see, it's a holiday. So we will not meet that week, and so on. I'm still admitting some people. Okay. All right. So that's the website. And as I said, I discussed some of the tools. Now let's go back now to Brightspace. Yeah, so let's go back to Brightspace. Okay, I think this. All right, can you guys see Brightspace?
Yes.
All right.
Yes.
So Brightspace, this is the course site. Certainly your grades will be posted here, and homework assignments will be posted here with their respective drop boxes, and then you guys can submit your assignments. If I have announcements, I guess I will put them here. And then the other thing I'm using is this section called content. And you can see content here. Basically what I do is I click on table of contents, and then I have all of your materials are here. So everything will be here, right? You can think of each of these as a module. So I will put lectures and labs in the same module. So for instance, I've already gone over the syllabus, but if you want to look at it, you click on admin, and then you can see a link to the syllabus. If you want to find the Zoom information, I provided a text file here. If there's resources that we need, I will provide information here. So for instance, if you're a little rusty on Python, I would recommend that you maybe go through this document here. It's not something I will cover in the course, but it's like a background to practice some things of Python. Or you can, as I said, you can always just find a lot of great videos on, on YouTube. Then you can see here, I've added a link to Anaconda, so I'll come back to that in a second. Some of the tools that I want you to install for basically for next week. All right, and then you can see after that, it's just the different modules of the topic. So I'll start with intro, then, you know, supervised learning, kind of motivate that, performance metrics, right? So you can imagine these three are just like the overall introduction to machine learning. The machine learning pipeline, if you will. Now, machine learning is usually divided into supervised learning, unsupervised learning, and reinforcement learning. Those are roughly the three ways in which you can break it up. And the way that I have it is, you know, most of the course will be supervised learning. Most of it will be supervised learning just because that's where you have a lot of things that you can do. Then towards the end, you can see there's unsupervised singular value decomposition. These are, and then I haven't added the reinforcement learning modules, but those roles are also going to be there. So let's just go over some of the topics so that you're familiar with this. As you can see, today's lecture that I'll probably start this one today. You can see I have a slide. Basically, there's no lab, but if there was a lab, it would be here. And I believe that I'll be able to create drop boxes here for homework. So everything will be self-contained on a per module basis. Okay? Then there will be information on supervised learning. Keep in mind that I have a tendency to post PowerPoints, but then just write on a whiteboard. Okay, now usually what I'm writing on the whiteboard is exactly what's on the slides, but you know, obviously you need to, you can't just read the slides, right? You need to pay attention to what I'm explaining in the whiteboard. So as you know, Zoom has a nice whiteboard, and so I'll be writing on it. Okay. Then as you can see, we'll cover performance metrics. Oh, sorry, I clicked on the wrong. Performance metrics, you can see the slides there. Performance metrics is one of the topics where it starts to get real, you know, it starts to get a little bit tricky to understand. So, you know, we'll spend an entire lecture of this. It's very important. Then after that, as I said, the very first machine learning tool that I discussed with you guys is something called Weka. So Weka is something that I strongly recommend that you install. See there, I have some slides and some documents there. So Weka is a program. We're not going to spend too much time on it because not too much time is required to understand Weka. It's a GUI-based program. But what's really great about Weka is that it allows you to see the entire machine learning pipeline really quickly. And so, and you can always use it. I always still use Weka, even though, for instance, I'll give you an example when I use Weka. So Weka is not necessarily like a GPU type of an application. But sometimes, let's say I have 10 million records of something, right? 10 million samples of data. That's a lot for my laptop. But I just want to get a picture of the data. So what I can do is I can write, you know, a script in Python, and I can randomly, out of those 10 million, select 100,000 samples, right? And if I select 100,000 samples, then I can just take that 100,000 samples and really quickly benchmark it on Weka. So I can use Weka to basically get a picture of the data. I'm not analyzing the entire data set because, you know, I might run into memory issues, but I can use Weka to kind of get a picture randomly of a smaller subset of the data. And what's great about Weka is that you'll see it's very nicely done. It's been around for decades, or at least a decade. And so it is really versatile, and it's a very good introduction to machine learning. I'm pretty sure you're going to really like how it works, how intuitive it is. And so that will be your very first tool, okay? And that's a Windows, Mac, or Linux tool. So at that point, you know, you can use your Windows machine easily. Okay, so this will be our very first, your first lab will also probably be Weka. Okay, just a very simple data analysis. Then after that, we're going to talk about features and data sets. So as I said, a lot of machine learning is just dealing with data. So I'll go over this. I have some slides here. We'll cover this at some point. You will learn what features are. You will learn how to deal with data. And that will motivate that dealing with data means processing a lot of data. Okay, so it'll mean processing a lot of data. Now, that will take us to something called NumPy. How many of you have heard of NumPy? Has anyone ever used NumPy for anything? Show of hands. Ah, great. So some of you have used NumPy. That's really great. Excellent. And so we're going to hit NumPy really hard, okay, this semester. What is NumPy? NumPy is just like TensorFlow, is a library in Python. So how can I put this? Let's say that you have 1,000 records of data, right? 1,000 lines of code. And you have to iteratively analyze that data. What do you need to write usually in your program? You need an array, very good. So somebody anticipated, you need a type of an array. How do you traverse arrays that are two-dimensional? You know, we all did this in programming, right? We all have the classic example of I have a two-dimensional array with an I index and a j index. I need to get all the data, multiply, and transform that data by multiplying it times 3 or something like that. What do you usually do to solve that problem? What would you say? Who wants to take a stab at that? Again, you have a two-dimensional array, you have the I index, the j index, and you want to look, maybe print all the values in the array. What do you need? What would you answer? What would your answer be? Let's see. Loops. Excellent. So exactly. A nested loop, correct? You usually think, oh, I'm going to do a nested loop. There we go. Now, let me see if I can, I want to switch to the whiteboard. Okay. Can you guys see the whiteboard now? Yes? Okay. So, great. So let me kind of write. So usually what I'm saying is you have a two-dimensional array, right? I, j. We all know how to do this. We learned this in school, right? And then we have values. You have a 7 and an 8. And then I'm asking you to analyze all that data. So what do? For I in range, right? And some value, let's say this is 6 and this is 6. And then you do another one for j in range. And then that's 6 also, dot, dot, because it's Python. And then you print, and let's call this m. And then you print m ij or something like that. Right? Do you guys agree with this? Did you see what I wrote? Okay, excellent. So all of you see what I wrote here. Now, and this is how you would solve it, right? This is how you would, intuitively, you would say, yeah, that's how I'm gonna do it. However, there are a few problems with this, unfortunately. So who can tell me what's the problem with 2 nested for loops to solve this problem? What would be an issue? I mean, it's perfectly good code. I'm not saying it isn't, but what might be an issue with this? Who wants to? And you can talk, guys. I mean, it's. Let's see, you guys making me read this chat. It's slow, very good, excellent, thanks, Mitch. Exactly, the problem is it's slow. In fact, very slow. And so, as I said, whenever you get confused about this, my insistence on why are things slow, just remember video games. You're gonna get really bored if you're playing a game, Fortnite or something like that, and it's just very slow, right? It's the same in machine learning. Remember, you're gonna be dealing with large amounts of data, and so you want your code to be very, very efficient, right? So one of the goals in this class is that I wanna show you, you're still gonna use for loops sometimes, but we're gonna learn a new approach where we don't use nested loops, to solve array types of problems. Instead, we're going to use what is called the Numpy library. Okay, the Numpy library is a library that allows you to perform operations kind of in parallel, or operations that are faster than using two nested for loops, for instance. So that's, let's just think of it that way. Okay, that for now, we're going to use NumPy because it provides alternatives to dealing with data that are much more efficient than two nested loops. Okay, so there's a lot of libraries out there for doing things like this. There's also something called Pandas. I'm not going to look at Pandas that much this semester, but I'm certainly going to introduce NumPy arrays and tensors and tensor operations. Okay, NumPy is a lot more. Well, actually, I should say they're actually almost the same. So it's almost like TensorFlow just looked at NumPy and then they just created all the same functions in NumPy in the TensorFlow library. So they did it because of efficiency things so that everything was compatible. But usually you can almost use them interchangeably. Okay, and so, but we're going to start with NumPy is the more established library. I just want you to understand that NumPy by itself is not a machine learning set of algorithms or technique. NumPy is really a library for manipulating data. But if you think of applied data science, applied data science is about that, right? It's about data. So it's the science of data means that you have to, before you can actually infer things and generate information from data, you have to manipulate the data, transform the data, deal with the data, okay? And so we're going to be using NumPy. And so one of the many things you'll learn in this class is that, I'll show you alternatives to two nested for loops for solving problems. Does that make sense? Okay, great. So, excellent. Let's go back to share. I was going over this. So let's go back to Brightspace. So you should be looking at Brightspace now. So what I have here, this NumPy examples, is really a link to my GitHub. So I have already worked out a series of exercises with NumPy arrays, okay? And so that's going to be one of the homework assignments for you this semester is, I'll show you NumPy. The best way to understand NumPy is really to do exercises. One thing that's critical for you to understand is a technique called broadcasting. So broadcasting is essential when you're doing operations in machine learning, dealing with data. So I'll cover that. I should stress that we're going to see that, basically you have data and then you're going to apply, math operations like addition, sums, multiplications, and so on. We're going to touch lightly on an area called linear algebra. So linear algebra is a technique in mathematics that allows you to perform specific operations on matrices and vectors, which that's like saying on two-dimensional arrays and one-dimensional arrays. So for instance, I'm going to want to multiply two elements, right? And we're going to now, because we're dealing with a lot of data, we're going to see that there's performing a multiplication that is element-wise versus a multiplication that is a matrix multiplication. So there's going to be differences between them. So there's quite a bit there, but don't worry about it. The best way to cover that will be, as I said, with examples. And it's just, as you will see, it'll just give you more power to deal with your data later on. Okay, so anyway, so that will be, I'm just kind of motivating the topics right now so you know what's to come. So this should be a very fun lab, I think. Once you've mastered, at this point, you will have looked at Weka, so you will know the basic pipeline of machine learning. And now we're kind of in that phase of features, understanding the data, the libraries for manipulating data. So the next step will be, if you notice here, are you guys seeing the Brightspace? You seeing that? Just want to make sure you're following.
Yeah, we see it.
Great. So the next two topics are data scraping and Twitter. So like I said, one of the goals is we can always get data sets from the web. There's a lot of data sets out there. I'm sure you've heard of something called Kaggle, and Kaggle has a lot of data sets. So I suggest if you haven't done so already, create an account in Kaggle, because I think you'll need one to download the data set. Start reading through Kaggle, okay? And you know, just becoming familiar with it. You'll find a ton of information there that's very, very valuable. So we will, you know, I will provide data sets that I'll post on the website, on Brightspace, or I will also refer you to Kaggle, or sometimes I will actually ask you to get your own data, right? So it's important that you understand ways of getting your own data. And for that, we're gonna look at something called data scraping. Right, you can see here I have, that's a lab, basically shows you how to get data. This actually, within this, you probably heard of web crawling. Web crawling falls under this topic. Web crawling is actually a topic in information retrieval, but it is relevant to data scraping. All right, and then we'll see how we can also get data from sources, for instance, Twitter, right? So Twitter is, you know, as you know, it's got tons of information, and so you'll learn how to get data from that source. Is everything clear so far, as far as the topics? It seems like everyone's following along. All right, once we've covered the topics and we've spent a lot of time on data, basically, we're gonna move on again to machine learning. All right, so this is the phase where I would call these next 3 slides are what I would call the traditional machine learning phase. We're gonna look at a library called sklearn. I'm pretty sure you're gonna love sklearn. It is a Python-based library, but it's very easy to use, okay? And so we're gonna look at sklearn. This is where you will actually be able now, instead of being limited by Weka's GUI interface, now you will have a Python-based, scripting-based approach to using machine learning algorithms. Okay, and so we'll spend enough time on sklearn. It actually doesn't. You don't need that much time to get going with sklearn, but that will be like, let's say, your second set of machine learning algorithms. I usually like to teach KNN and naive Bayes. The goal here is that we're actually going to look at writing these algorithms from scratch. Okay, so there's 2 lectures that I will explain, and then maybe as part of the homework, I will give you the pseudocode. I'll explain the pseudocode, and then I'm going to ask you guys to write naive Bayes or KNN. So here, this will be a great example of NumPy arrays, right? Because you could write naive Bayes and KNN with for loops, right? You might imagine that. But you can also write them with NumPy arrays, right? And what you will see actually if you write them with NumPy arrays is that the performance will be faster, okay? Because I think I said this already, but if you remember, Python is nothing more that someone wrote an interface for C, C++. And so NumPy, the underlying NumPy binaries and everything are C. And so they're very efficient and fast. They perform things in a more parallel approach. Does that make sense, guys? So here, not only will you learn about these algorithms from scratch, there's pseudocode, but you could actually implement them for loops versus NumPy arrays and see the difference. Okay? And this will provide some frameworks. This is more of a probabilistic approach based on the base formula. And KNN is a very simple, very, very, very simple machine learning algorithm. So you can actually write both of these from scratch. All right, questions? All right, so once we've covered that, sklearn, naive Bayes, KNN, we are pretty much done with traditional machine learning algorithms, okay? And then we'll be ready to move on to what I would describe as big data types of machine learning, okay? That will bring, as I said, for this course, we're gonna use TensorFlow. I'm not gonna spend too much time on the algorithms of TensorFlow. Instead, we're gonna look at other things that I usually don't get to cover in the deep learning course, right? So this is gonna be more of an introductory to TensorFlow kind of a thing. So for instance, when we look at unsupervised, we'll do it on TensorFlow, things like that. So the first thing is, basic introduction to why TensorFlow is important for parallel computing. How does it do things like batch processing and all of that. Then we're gonna do, just like I did with NumPy arrays here, we're gonna do the same, but now with tensors. So my goal is that, once again, I wanna show you broadcasting on tensors and just performing math operations. So I keep throwing at you the word tensor, right? I keep saying tensor. You probably don't even know what tensor is. Is there anyone that knows what a tensor is and can give us a definition? Anyone want to try? Feel free to speak. Just give us a short definition of what a tensor is. All right, I'm gonna see if I can pick someone. Nobody? Can you guys hear me? You guys still there? All right, let's see. Who is here? Joe, Joe Usabel, you wanna try what a tensor, define what a tensor is?
I was speaking on mute. I'm looking at my notes from last semester. Drawing the blank.
Okay, that's fine.
I know we spent a lot of time on it though.
Yeah, don't worry about it. So a tensor is nothing more than, an array. To put it in terms, if you have a one-dimensional array or a two-dimensional array, that's a tensor. So now you have a common term that defines the array, and then you just know that it has a specific dimension. So what do we call a three-dimensional array? What's usually the name for that? It's a cube, right? A cube. And then, you can have, although we can't visualize cubes of more dimensions, we can have four-dimensional cubes, five-dimensional cubes. They're basically just called tensors, arrays of multiple dimensions. And this is important because there's a lot of tricks that you can do with these tensors. And so that's what we're going to explore. And it's not just about data, but sometimes it's about representing data, representing states, and reinforcement learning. There's techniques for that. And so we'll talk about that, right? So as I said, my goal will be to look at tensor operations, get you good at understanding all those structures, broadcasting, matrix multiplications, and so on and so on. All right, then after that, I will cover the contrast between the TensorFlow low-level API, which is basically the computational static graph, and that's the first thing that you cover when you talk about parallel computing. I won't spend too much time on that because that's something that I spend a lot of time in detail in the deep learning course, and so instead I'll just kind of show it for contrast. But really, we will actually look at TensorFlow 2.0 this semester. So for those of you that are familiar with the Keras library, right? So Keras is supposedly like an sklearn type of library for TensorFlow. So we will look at that. I don't want to say Keras so much because Keras has been integrated into TensorFlow 2.0. So really, we're just going to refer to it as TensorFlow 2.0. I want you to know that TensorFlow 2.0 is really like, that expression like hot off the presses, right? So it just came out. And so if anything, that just shows you that things are constantly changing, okay? So we're going to explore this idea, okay, as I said, my goal this semester with a machine learning class is not to get so deep into the algorithms, and instead it's more to give you more of a higher level so that we can move a little bit faster, because getting in, programming in the low level API takes a lot of time. And so for understanding things. So, I'm not necessarily going to take that approach for this class, and instead of coming from the bottom, if you will, bottom up, we're coming top down. That makes sense. All right, so anyway, so TensorFlow 2.0, certainly, innovation that's going on. We won't have time, unfortunately, to cover PyTorch or other platforms. I might just give you some references to them, but we have to stick to one. After that, as I said, that will be parallel. Then we will move on to unsupervised methods. I want to cover quite a bit of that this semester. Unsupervised, we can do in Weka, sklearn, and TensorFlow. So we will cover it in all mediums. And as I said, I like to cover recommender systems in this course, which, if you remember, that's what I said is what Netflix and Amazon do. What can anyone, so what would you say? So obviously the name implies it, but how would you define a recommender system? What is that? Who can tell me what a recommender system probably is? What's a recommender system? I'm going to pick someone. Let's see. But don't be shy, Feel free to talk. Neil Buss, you want to try? What's a recommender system?
Isn't it like, can you hear me okay?
Yes, I can hear you.
Okay. Isn't it like where you give something like an algorithm and it'll spit back you like a recommendation on what to do next?
Exactly. It's an algorithm. You said it really well. Perfect. It's an algorithm to predict the rating of any recommendation a user can give of something. Very good. Exactly. So that's the idea. Our recommender system is that. It's kind of an unsupervised approach where you have, you have ratings, right? For movies, for books that you like, you're really into like skiing, right? And so basically what that does is it tries to recommend other products, okay? And so, Netflix does that, Amazon does that. And so we're going to cover it in this course, recommender systems. That gives us, I love recommender systems because it gives us an opportunity to look at some very interesting underlying techniques. Yeah, so a recommendation algorithm is actually going to be based on something. And so as it turns out, that's based on something called matrix factorization, and in particular, a technique called singular value decomposition. And so singular value decomposition is great for several things. And so we will look at that technique, which can be used for recommender systems. It can also be used for data compression. And so that actually will allow us to talk about that very important topic of data compression as well. Okay, and so we'll cover that at some point in the semester. As I said, the order of these topics might change a little bit. I'll move them around as I see. And then the last topic that I have not included here is reinforcement learning. So that's a topic I'm going to cover quite extensively this semester, okay, because it's becoming more and more important. So you're all familiar with self-driving cars, right? So how many of you believe that, let's say 5 years from now, you'll call an Uber and then you'll get a an Uber without a driver? How many of you?
Well, I mean, even Tesla's getting to the point where they're saying they want to have it so that you can be in California and you can call your car back to you while it's in New York and it will completely drive back to you. I think they said that they wanted to happen within the next couple years even.
Yeah. So at least you believe that it'll probably happen.
Oh yeah, I can see it coming within the next few years.
Exactly. Very good. So so we're gonna cover it. So I actually built this over the summer an API. So for that kind of thing, like an autopilot. And so I will show you guys how to integrate that autopilot into anything. You know, I integrated it into a simulator, like a flight simulator. But I will also give you some suggestions if you actually wanted to look at how it would work in self-driving cars. Obviously, you know, you're probably not gonna buy a Tesla and test your algorithm there, but you can always test it on these little robot car platforms. So we'll cover that a little bit. I'll show you what's available out there. And then I'll give you the instructions. The great thing is that it's written in Python, and there's Python libraries for robotics, right? So you use the Raspberry Pi is very versatile, and so you can achieve a lot of things. So we'll look at it from that point of view. A lot of people traditionally use something called AI Gym, and we will also explore that AI Gym. I should say reinforcement learning is not deep learning. Reinforcement learning is a field of machine learning. However, you can take reinforcement learning, add deep learning techniques, and make it a deep reinforcement learning algorithm, if that makes sense. So we'll talk about it. That's a topic that it depends on the interest in students. So I need to see what students want to do this semester in particular for their projects, because I can always teach on supervised last, reinforcement learning, you know, so I'll figure out the order. So as I get to know you guys better, I will be able to figure out the order of the topics. You know, it's not really that problematic. But anyway, I think it's definitely a topic that you will like. And it's actually not that difficult. It's actually quite interesting, not that difficult. All of the topics are in the book, as I said. So if you go ahead, buy that book on Amazon and start reading. If not, I will provide all the materials, lectures, and labs, so you don't have to buy the book at all. All right, and that's if I'm not missing anything, I believe that is the set of topics for the course. So as I said, this is a course on applied machine learning. So I wanna stress one thing here. So I'm gonna share the whiteboard again. Can you guys see the whiteboard? I assume that's a yes. All right, I want to change the color because I don't like that color. All right. So okay, here we go. So let's see. Let's start with that. That's AI. All right, you can see that that's artificial intelligence. Okay, artificial intelligence. Then within artificial intelligence, there's machine learning. Okay. So what's outside of machine learning within AI? Well, if you remember, I told you that Claude Shannon, who is extremely important, right? Created learning theory, theory of communications. So not learning theory, but theory of communications. So Claude Shannon was interested in playing a lot of games. He was really doing reinforcement learning, right? So look him up. you know, I'm pretty sure someday they're gonna make a movie of him. He was a very eccentric character, but he did, you know, I told you like the mouse game question. So mouse game, chess, for instance. You guys, I'm sure some of you have played chess online. So those are games that sort of could fall there within AI, but not necessarily machine learning. You know, it's basically a lot of rules. You know, chess is really a game of rules. There's a lot of what are called heuristic rules, and you can have a lot of success just doing that, right? And so that's AI. But machine learning within AI is really algorithms that take data. So what I want you to understand is that you as the programmer don't go in and you don't have to code, the rules or the heuristics, okay? You don't have to do that. Instead, you just rely on the algorithm to look at data and learn. Or in the case of reinforcement learning, you let the algorithm look at the sensor. So you know, for instance, a self-driving car, right? Self-driving car has a lot of sensors. It's constantly looking at them and updating, making updates based on what it's seeing. And so that's what machine learning is, okay? So I want to stress that. This is kind of the picture. Now, deep learning, which is not something, as I said, I'm not so much going to cover, or not at all really, cover deep learning. I might cover neural nets. And I might even take it to the point of, oh yeah, this is a neural network with 2-3 hidden layers. Okay, that's a deep learning. But I'm not really going to stress too much in deep learning because that's the next class. But I just want you to understand that deep learning is really here. Now, we want to stress that deep learning is very, very powerful, and so you must mention it quite a bit. But if you see it, it's nothing more than artificial neural networks, which is one of the techniques, right? One of the techniques in machine learning. So it's a sub-area within machine learning, and then machine learning is a sub-area within artificial intelligence. Does this make sense, guys? So that's an important, you know, I like putting things into context, and so this is definitely important. All right, sometimes when you hear me pause is I have to reach to this chat room, and so it takes me a second. All right, so now that you see, and you guys can see my writing on the whiteboard, I'm assuming, so that hopefully that's easy. I will be using this a lot. You know, I like to write on the board, so this works out perfect for me. All right, another thing I want to stress, you know, since I've talked about the topics, so the class is applied machine learning. So as I said, you know, most of what I will cover in the course is intuition. I like students to have a good intuition of what they're doing, you know, so I'll provide examples of that. We're not going to do, you know, obviously, you know, any algorithm that you write in computing is based on math, you know, science, you guys know that. And so all of these algorithms have some theoretical mathematical framework, obviously. We're not going to be doing any proofs or anything like that. That's not really part of what we're doing here. So it's really the focus will always be on intuition. It'll be on programming. But really, a lot of the algorithms, especially now with TensorFlow 2, there's a lot of abstraction going on. And so I will kind of decide how much I want to get into the details of the algorithm. Okay, but as I said, I'm starting from the very top. So the focus of this class 520 will be more of a top-down approach rather than the deep learning class, which is definitely a bottom-up approach. All right, so we'll be looking at a lot of intuition, programming, of course, and using the tools, and then looking at problems. So that's one of the things. So a lot of the work that we, as you know, a lot of you are cybersecurity scholars, and you have a very strong interest in cybersecurity. So certainly one of the goals of this course is to show you how to apply machine learning to cybersecurity. So we can look at it from the point of view of, intrusion detection systems, malware detection, and all kinds of things like that. So we'll look at those types of problems. We'll also look at problems in healthcare. We'll look at just the classic problems like the IRIS data set. We will look at NLP problems because, a lot has been done. NLP stands for natural language processing, so that just deals with text. Image processing, finding cats in pictures. As I said, unsupervised, and reinforcement learning, which is the idea of, as I said, autonomous vehicles, for instance, probably the best example. All right, so we will, those are the problems. So that's why I wrote looking at problems here. Okay, problems. Now, I will cover, because I'm doing a top-down approach, I will cover a lot of the libraries, a lot of the function calls, how to write the code efficiently with NumPy and TensorFlow. But sometimes it is important to look at the equations. Sometimes the equations provide the best intuition that you can ever get. So we will look at that. Now, I'm not like for those of you that have taken my deep learning class, the approach here will not be like start at linear regression, logistic regression. We're not going to do that here. That's in the next course. But certainly, I will talk about optimization. You have to understand that in the context of what's going on. There's a lot of algorithms out there, for instance, support vector machines. Obviously, if an algorithm has become, how can I put this? If an algorithm has been now displaced by another algorithm, then I'm not going to stress it, okay? I'm only going to stress the techniques that are right now very important, okay? So anyway, so that I wanted to stress that about the class. So intuition, programming, looking at a lot of problems, and when we have to, we will look at the theory. Whenever I feel that it'll help you to grasp things better, we'll get into it, okay? Right, but I think, as I said, you will really enjoy the class. All right, so that's, I believe at this point, I just have one more thing. So I'm almost done with motivating the class. And then I'll just start the lecture, basically, like formally get it. But I do wanna point out some of the tools. Are you guys seeing my Brightspace right now?
No, I don't see it.
No.
Are you still on the whiteboard? Okay, hold on. So I'm going back to Brightspace. Okay, I'm on Brightspace now. Can you see it?
Yep.
Okay, great. All right, so if you go to resources or the website, I've provided some links. One of the links that I provided is this one called Anaconda. Right, so if you click on this one, it'll take you to a website over here. So this is not like Conda where you install that in Linux. And I think, I usually teach that in 372. For those of you that have seen it, Conda is just like for manipulating versions of software. That's certainly something you'll have to use. But that's on the terminal in Linux. But there's this called Anaconda. You can see the website. You guys can see it, correct? Are you guys seeing?
Yes.
All right, it says your data science toolkit. So somebody wrote something. All right, great. So this is one of the many tools that you're going to install this semester. This runs on Windows, so you can just easily install it. It is a little bit big, unfortunately. It's like 3 gigs, but I think usually your VMs are way more than that anyway. So you just need to make sure that your computer has, 3 gigs. I think with 8 RAM on your laptop and 3 or 4 gigs should be good. So definitely install this. I don't have to sell this. I mean, literally you can see your data science toolkit with over 20 million users worldwide. The open source individual edition is the easiest way to perform Python, R, data science, and machine learning on a single machine. Developed for solo practitioners, it is the toolkit that equips you to work with thousands of open source packages and libraries. And it is very true. This will have a lot of the libraries that we need. And so definitely go ahead, get started on installing, as I said, Anaconda. If you scroll all the way to the bottom, you can see the installers right here. Sorry, here it is. Anaconda installer. So for those of you that love Linux, go ahead and install that one, or Mac, have that one, or the Windows operating system, Windows 10, and you'll have that. So those are the installers. Should be pretty straightforward. Okay, so it runs on both of them. If you notice, it says Python 3.8. I want to stress that we're going to be using Python 3 and above. Okay, so I know 2.7 was around for a long time, but everyone's using Python 3. So certainly make sure you're using that one. Okay. So this will be one of the programs. So today, as I said, I'm just really talking about tools. This is free. It should not cost you any money. So you can see it's got Python there, Conda packages. It's got R, but R is, as I think I mentioned, it's less. I mean, it's important, but not as popular as Python. You can see here, build machine learning algorithms. We got PyTorch in there. Let's see, somebody wrote something. So here's the thing. You do not have to do any of the things that I say. Instead, what you should do is you have to solve the problems. So for instance, if you're one of those people that just, you want to work on Linux and you're just going to work on terminal and you're going to install your own libraries, hey, you can do that. Perfectly fine, no problem. However, usually I have a fair number of students. I work on my Mac and I love Linux, but usually I have a good number of students that, prefer Windows, right? And so if you're one of those that prefer Windows, well, then this is an option for you, okay? Not everything that we do will be able to do on Windows. So there might be some things where we have to use other environments. So it's up to everyone to make your decisions, okay? I'm just providing tools here because anything that you do, you can always just have Python and NumPy and TensorFlow on Linux, right? And that'll do everything. Or if you just want to try Anaconda and have everything in there, well, that's also an option, okay? So basically what I'm giving you is options. How you end up, your environment. If you want to build your own GPU box, by all means do that, okay? There's a lot of ways. Or maybe it'll turn out that, if Scholar gets working, West Lafayette Scholar, hopefully we can use that as well, right? So a lot of solutions. Certainly in data, in applied data science, we have a lot of options, a lot of tools. And at the end of the day, the algorithms can be used in one or the other. Sometimes maybe the versions give us some problems, but otherwise it's pretty flexible. Does that answer your question? Okay, great, excellent. So anyway, so going back to, as I said, whatever your preference is, by all means. However, I wanted to stress with Anaconda here on Windows, I do find it to be probably the simplest thing for you guys to get started. It's got PyTorch, TensorFlow, Jupyter Notebooks, NumPy is there, sklearn is here, Pandas, although we won't use Pandas or Matplotlib that much, and so on, right? So some of the important ones are there, and obviously Python is there. All right, so certainly install this one. All right. And then it's pretty easy to use. All you have to do is after you install it, look, if you're, let's say you're on the Windows side, after you install it, go to your, like your little home icon of Windows and there look for Anaconda and then either start a Jupyter Notebook or there's a terminal also there. And so, obviously you'll have to, I'm not gonna, what I wanna stress is I'm gonna let you guys figure this one out, okay? So you know how to write, all of you know how to write Python code pretty much. So what I would recommend is install, if you're gonna use Windows, Anaconda, and then start writing some Python scripts and running them there. If you can run your Python scripts, then you'll be able to do a lot of the things because everything else just involves importing NumPy or importing TensorFlow and so on, okay? For those of you that want to use the Linux side, as I said, my recommendation, install Conda, create an environment with specific versions and work through that, right? So if you have a physical machine, and so you have multiple options, okay? So I wanted to stress this one. Are there any questions about Anaconda in this environment? No questions? Everyone clear? Seems like everyone's clear. All right. Can you guys see are you guys seeing a website called Weka here? Yep. All right, the other tool that we're gonna use, actually this is the very first tool that we're gonna use this semester. It's called Weka. I like Weka. I've been using it for a while. As I said, this is a very, very much, the way we're gonna use it anyway, is very much a GUI type of an interface. Now, I strongly like coding and doing things in Python, but Weka is certainly a tool that I need to mention because it is important. As I said, I like it for just prototyping things or calculating baselines, getting a picture of my data really quickly. So just, a little bit of information here. Weka is a tried and tested open source machine learning software that can be accessed through a graphical user interface. And it's Java-based. It is widely used for teaching, research, industrial applications, and contains a plethora of built-in tools for standard machine learning tasks. And that's really how we're going to use it. I don't want to use it in other ways, to be honest. But I will cover all of this in a lab, probably next lab or somewhere down the road. So definitely make sure that you install this, okay? Install this program. This one also runs on Windows, Mac, and Linux, okay? And so just install it, make sure you have it, and then our very first data set will probably be the Iris data set. And I'll just show you, through this tool, I'll be able to show you the complete machine learning pipeline really quickly, okay? So you'll be surprised at how quickly with this tool you'll be able to do machine learning. All right, so this is another one of the tools. So is this clear? Everything clear, related to Weka? Are there any questions? All right, seems like there's no question. So, okay, so that's pretty much all the tools. So you have, that's your homework for this week. Install Anaconda, installed Weka, get set up with Conda if you're using on the Linux terminal. And, as I said, there's a lot of tools that we will be using, and then that way you'll be ready to get going. Make sure you have a computer, that has good amount of memory, even if you're using a VM, make sure you allocate enough memory. Now, as far as the cloud services, as I said, that's something that we're just getting set up with. So as time permits in the next 2 weeks, hopefully, I will provide instructions on how to, if we get access to that West Lafayette cloud, also that will come in as additional instructions. Remember that the idea there is to have access to powerful GPU boxes and more powerful computers. Okay, so that concludes, and I think that officially concludes now just a kind of overview of all the topics, and we are ready to get started. All right, so I'm going to switch back to the whiteboard. Okay. Can you guys see the whiteboard? All right, excellent. So we were, if I go back to the slides, we were talking about machine learning, AI, and then machine learning is a subset of AI, and then within machine learning, there's an additional subset called learning. All right, so now let's kind of think about just machine learning as a whole. I'm just going to write here machine learning. And really, machine learning is roughly divided into 3 areas, okay? And that's the first thing that we're going to learn in machine learning, is that it is roughly divided into 3 areas called supervised learning, unsupervised, and actually let me do this. I'm going to put unsupervised here. Unsupervised learning. And then in between, we're going to have reinforcement learning. Okay, so that's the difference, okay? And so basically the idea here is that whenever you have a sample of data, when you're looking at supervised learning, you have an associated, what is called label. You have something additional that correlates to that sample, okay? So this one has, oops, this one has labels. Unsupervised is the total, the other end of that spectrum or range, where you have no labels. No labels. And then, as you might imagine, then reinforcement learning is something kinda in between, where the algorithm doesn't have labels per se, but at the same time, it's not like there's nothing to learn from. So it's somewhere in between. You have a set of rules or heuristics or some kind of thing like that that gives you a reinforcement. And usually this is referred to as the reward function. Reward function. Okay, so we'll talk about that this semester as well, right? So that's really the 3 main things. So really the big gorilla in the room is this one, supervised learning. This, as you will see in the class, it'll cover a little bit more. It's the more traditional thing that has been around more. Unsupervised is the thing that when you have a lot of data, when you have something that's really expensive with relation to data and resource intensive, okay, you gotta start with something, so you start with unsupervised. And then reinforcement learning is somewhere in between, but it's actually very, very interesting. Reinforcement learning is actually quite amazing if you think about it. And so we will definitely discuss this topic. So one way that I can put this is, for instance, let me say this. Very rarely, so first of all, there's no Nobel Prize in math. There's no Nobel Prize in computer programming, right? There's no Nobel Prize in those fields. And rarely do you get machine learning research published in journals like Nature or Science, which are the top journals in the world. Yet, the only thing of the area of AI, machine learning, or deep learning that has been published in recent years in a top journal of like Nature or Science is something related to reinforcement learning, right? So there was a paper, it's called AlphaGo. AlphaGo was a set of algorithms that use reinforcement learning. And those algorithms learn to play Atari games, the old style 2D Atari games from the 80s. You ever played, have any of you ever played Atari games? Do you even know what Atari is? Let's see. Yes. Yeah, exactly. So Atari games, you know, I won't. Right. I still have my Atari console. So Atari games are like, I think Space Invaders was a famous one. So if you remember, there's 2D type of games. Well, it turns out that some people, I think at DeepMind, which are these institutes of AI, they developed a set of techniques to play these games, these Atari games, and the algorithms learn to play the games at the levels of human experts, okay? And it was amazing how they did it. So it was so interesting what they did because it's an advancement on AI that is so significant that it actually got published in papers such as Nature or Science. I can't remember which one, but I think it was Nature. But my whole point is that of the 3 areas of machine learning, this one is impressive. And hopefully you will see that. You'll see that it's actually pretty straightforward. And so, but really what you do need for these kinds of things is a lot of computing power, right? So that's why, you know, you need GPU boxes and so on. All right, anyway, so we'll talk about all of that. If you like watching documentaries on Netflix and things like that, you can watch a documentary on something called AlphaGo. I think it's Netflix or YouTube. Look it up, and it'll give you a little bit more an entertaining, you know, description on reinforcement learning. But anyway, we'll cover all of these, and I just wanted to stress that about reinforcement learning because I'm always amazed by it. I think it's such an interesting thing. All right. Anyway, so when you talk about machine learning, this is how people usually divide it. You know, they usually divide it into these 3 areas, and you can see the common theme is that this idea of labels, right? So it goes from labels to no labels and something in between, okay? So we will certainly cover all of this this semester. I will probably start with, I will definitely start with supervised learning, and then depending on the interest of students, I will possibly go in this order actually. Probably makes sense to do that. So we'll cover all of these topics. So anyway, you know, you go to any book, I mean, in this book by Sebastian Rashka, you know, you'll see, you know, the very first, the classification that he also has in there, it's exactly like this. Okay, so now we only have about 10 minutes left. I've talked about all the topics of the course, given you a little bit of context, hopefully history. And we talked about the tool. So your homework assignment, remember, is about getting set up your entire environments, you know, download VMs, you know, install programs, have your Linux, Windows, whatever, Parallels, all that set up. Okay, so we've covered all of that. And now we're really just getting into the topic of machine learning. So now the last thing that I'm going to cover today is really this idea. So since I've introduced the idea of how do we divide machine learning, and we divide it into these three areas. So as I said, it's really like a range, right? So it's really like a range from labels to no labels, or something in between. So what do I mean by these labels, no labels? So that's really the next thing. All right, so and let me open it up to you guys. What do I mean by labels versus no labels? How would you give me an example of what I mean by that with data? How would you do that? Anybody? All right, I'm going to pick on someone. So anybody want to? Labels, no labels. Mitch, you want to try? You want to take a stab at this?
Yeah. So if you're trying to predict a 1 or a 2, the data would be labeled as a 1 or a 2. And if you're as a supervised approach, unsupervised, it would basically learn from a black box that what a 1 or a 2 is.
Right, exactly, right. So the key word I would say it's correlation. So what machine learning algorithms do is they try to correlate things. So for instance, let's say that I have, and we'll conclude with this today, but I'm gonna go to the domain of image processing. Right, so I have 4 images. So don't worry, some of the terms you may not understand right now. You'll understand them. You know, as we go forward, certainly have to give you all the terminology. But basically, I have 4 images here. And so each image I'm going to call a sample. So sample 1, sample 2, sample 3, sample 4. All right, and then I have, so it's an image, you know, right, of a cat. And then I have another image of a cat, slightly different. And then over here, I have a kind of a bird. Do you guys see that? Right, you see that I have 4 images. They're all different, but 2 are obviously of cats and 2 are obviously of birds. So now I have a machine learning model. And what my machine learning model wants to do is it wants to learn that whenever it is given an image, let's say I'm going to give it an image over here, and this image right? That's another image, it's different. It wants to predict what that image, let's call it S5, what that image is. So in supervised learning, I need to have something called labels. So what that basically means is that for every image S1, I'm going to have a label. So here I have L1, L2, L3, L4. And that L, that label, is something. So for L1 and L2, what would be the label? Guys, so what would be the label for L1 and L2? Cats. Very good. Cats. And we don't usually, another thing with machine learning is that we don't usually encode words in there. We always have to use some kind of a numerical representation. So we're just going to say that cat will always be a 1. So then the label associated with the entire image is 1. What about for these two, S3 and S4? What would be the label for that?
2.
Hmm? Birds, right? Birds or number 2, exactly. So then it's going to be bird, number 2. So that means it's 2. Do you see that? Now, whenever we feed the data to the model, we need to provide these pairs of the sample and the label. So we always need to provide, so now I want you to think of the data here, right? Think of the data as S and L. So it's going to be 1, 2, 3, 4. That's the images. And then 1, 2, 3, 4. That's the labels. Okay. And so this data is going to be fed into that model. We'll learn how to do that later. And then the model will learn. And then what do I do? And this is supervised learning because you have labels. So then I'm going to give it this image. What does the machine learn? What should the machine learning algorithm do in that case for S5? Because it does it have a label for S5? No, it does not. It only has the input S5. However, the model, what it does is it predicts labels. So in this case, give a new label. Exactly, you're going to give it a new label. So what label do you think it would give to this image? Three or 4. It actually, remember, we already trained the model, and the model only saw images that were either label 1 or label 2. That's all it has ever seen. Okay, ever. Remember, these numbers, these are not the labels. These were the samples, right? So I just meant label 1, label 2 to correlate with S1. So there's only, we only have basically 2 labels. Or another way of putting this is a 2-class problem. The classes are 1 and 2, which is cat or bird. That's all the model learned. So now when you give it a new image, we're not training it anymore, we're predicting. So again, what would be the label for S5, do you think? Yeah, exactly. So now it's going to say, well, it's either 2 or 1. So based on this image, which one does it look like more? Does it look more like a cat or does it look more like a bird?
It's 1.
Hmm?
It's going to be cat 1.
It looks a little bit more like cat, right? Now, here's the important question. How does the algorithm know that it's going to be a 1 versus a 2? How does it know that it's more like a 1 than a 2? Yeah, those could be horns, right? Not ears. But the horns look more like ears than the wings of the bird, for instance. By features, exactly. So that's a good answer, is the fact that how does the algorithm know that this looks more like a 1 than a 2? Well, that depends on the specific machine learning algorithm that you're using for this model. You see that? So different algorithms in machine learning have different ways of learning to correlate a sample to a label, a sample to a label, a sample to a label. It finds patterns in the data, and then it builds these models, and then it applies models to different to the different samples. Okay, so that's what we're going to study, and that's why we're going to cover things like naive Bayes and KNN and maybe logistic regression, just to get a view of okay, the how. How does it actually learn to correlate or find these patterns? But in supervised learning, I want you to understand that you're doing this correlation. You have to have labels and you have to have samples. Whereas in unsupervised, you're not going to have any of the labels. So in unsupervised, and I'll just wrap up with that, there's no labels. Oops. So in unsupervised, all right, so in unsupervised, there's only this, okay? There's no such thing as labels. You don't have that. So in unsupervised learning is the same model, but if you look, we only gave it the images, we never gave it corresponding labels. So we can't use supervised learning algorithms. Instead, we need to use, again, unsupervised. And the unsupervised learning algorithms then will learn something. They'll learn some structure about the patterns. Maybe it'll find that, these images have this kind of strange shape, whereas these images have this kind of strange shape. But again, once again, that is how that's done is determined by the specific machine learning algorithm that we are using. All right, does that make sense, guys? All right, great. So are there any questions? So that's our time for today is 4:52. No questions? All right, so if there are no questions, then we will stop here for today. Today, as I said, was just really to motivate things and give you all the specifics. Next Monday, when we meet again, I will do a lecture and more formally kind of pick up where I left off here. We'll start with our lectures, and then probably at the end of that, we'll start using Weka just to get a little bit going with the machine learning pipeline, okay? So definitely have all the software installed and ready to go by next week. All right, so if there are no questions, again, then we'll stop here for today, and I will see you guys next Monday. I really like teaching this class, so I'm sure you'll enjoy it. All right, so have a good day.